And you are going to draw how you think that part of the plant vascular system would look on this plant. So let's first do a quick review. I know we just talked about this. Where does photosynthesis occur? I'm going to pick on Aliana. No. Olive. Where's the green part on the tree? The leaves. Okay, Olive, come on up. And I want you to write photosynthesis where you think photosynthesis occurs. What I recommend for the rest of you is you can draw a tree on the back of your notes, and I want you to also diagram what's happening up here. So Olive is going to write photosynthesis where she believes photosynthesis to occur. Oh, I like it. Nice and big. Do you need to ask for a lifeline? Okay, you can call on the lifeline. Very good. Excellent. Beautiful. That's okay. All right, I'll take that. Yeah. Thanks, Olive. All right, boys and girls. So we have photosynthesis happening in the leaves. Very good. What do we need for photosynthesis? Quick review from the other day. We need a couple things in order to make food for plants. What are those couple things that we need? Aliana. Yes, but not what I'm looking for. Sadie. We need sun. Come on up, Sadie, and draw a sun. We'll choose a different color. I wish I had more color exponents. We'll just use black for the sun. Nice black sun. Very bright. Yep, go ahead and draw it. All right, we've got a nice sun. Do you want to label? Let's write sun in the middle of the sun. I think it would be very accurate. I like that. I know. I just like words and pictures together when I'm doing my diagram. That's okay. All right, very good. We need sun. What else do we need in order for photosynthesis to occur? Isabel. Water, okay. But what is the other thing? Nash. Okay. But what's the two key components that we need in order to make plant food? Kohana. Sadie. There we go. Carbon dioxide. Come on up, Sadie. Okay. Do you remember how to write carbon dioxide without spelling it out completely? Aliana? Nope, that's water. Very good. Write it down. And draw an arrow showing me what the carbon dioxide is doing. And now that 2, we're actually going to write it down low. Nice. And is the carbon dioxide leaving the plant or is it going into the plant, Isabel? Good. It's being absorbed by the plant. We'll just draw that a little quicker. There we go. CO2 going in. And what about the sunlight? Also going in. There we go. Thank you, Sadie. Okay, so we have photosynthesis, it occurs in the leaves, we need carbon dioxide, we need sun, and then, let's just say, let's write it out, sun plus CO2 equals sugar. But if the sugar is made in the leaves, how do I get that to the rest of the plant? Nash. Phloem, the phloem. And what is the phloem? First, can you come show me how the phloem, like what direction the phloem goes and kind of roughly what it looks like? Let's actually.
Sun plus CO2
sugar and plant food are the same thing, sure. Ooh, nice. I love how he's drawing his phloem going from the top to the bottom. Cannon, are you diagramming along with us? Okay, draw this down, please. Nice. And can you show me some arrows showing the direction of the flow? I might need that to make it be a little bit bigger. Show me the direction of the flow that the plant food moves through the phloem. Excellent. Nice little arrows. Beautiful. Love it. Cool.
And can I explain why it kind of is on a human body?
Not yet. Sorry, I'll take that. Okay. And what was the other structure that we read about that takes water in the opposite direction? Kohana. The xylem. Kohana, come on up and draw the xylem for me. I'm going to label my phloem right here. Phloem. Come on up. Let's do, I think this red might work better. So again, what is the xylem's job?
Isn't it like rings?
It's like a little straw. We're imagining little tiny straws. Both the phloem and the xylem, we're imagining as little tiny straws. And what is the xylem's job? Olive. To move the water up. So we're moving because, right, water in plants is absorbed from the thing at the bottom called the roots. And we need to get it from the roots to the rest of the tree, right? So we need to move it up. Nice. And very much like arteries and veins in our own body, that's kind of what the phloem and the xylem look like in a plant. They function in very much the same way. Nice, Kohana. Let's see an arrow or two showing which way we're going. Nice. Love it. And can you write xylem kind of like the way I wrote phloem right next to it? I bet you could call it a lifeline.
X-Y-L-E-M.
Don't look at me. I didn't say it. You can call them people.
I know.
Is that N or M?
Oh.
Ask your class.
X-Y-L-E-M. Xylem.
Xylem. There's... Very good. Nice work, kids. Okay, go ahead and cap that. Cool. All right. So we are. How are we feeling with this? Feeling okay? All right. Noah. Not Noah. Nash.
Can I explain which one is which for the veins and arteries?
Pause. So yes, that would be a perfect segue. Does anyone know? So now we've briefed ourselves on how this looks in vascular plants. How is this comparable to the circulatory systems, the vascular systems in people or animals? Nash.
Well, actually, this is kind of funny because you did the opposite colors of what it is in our body.
That's a really good point.
The
Did not.
veins are like the xylem going back to the heart.
Okay.
And then to the lungs to get more oxygen.
So you're saying that we have veins that move in which direction?
Well, actually, they go both directions in our body.
we're going to pause there. Tell me the two structures that you're talking about. Veins and
arteries.
good. Pause. So the phloem and the xylem in plants are comparable to veins and arteries in people. And we are going to pause there. And we're going to watch a quick video, and then we're going to discuss, okay? Okay. I'm going to pause the recording. All right, so I'm going to repeat myself. So, Isabel, which one, veins or arteries, take blood away from the heart? Good, okay? And you can just write it up there and then maybe draw the direction that it's going.
Okay.
It's obviously not going to look like this diagram. That's okay. So, what is the whole point of the heart? Aliana? Okay, to stay alive. But what does it do to keep us alive, Carter?
It pushes blood in, it sucks it in, and then pushes all the blood out.
Okay, it pumps. I like it. What else does it do? Nash?
The reason we need it is because if we didn't have our
Away from
heart, then the blood that had the oxygen wouldn't get pushed to our heads or our legs or our arms or any part of our body, and we would die.
Right. We need something. We need that pumping powerhouse to get oxygenated blood from our heart to the rest of our body and then cycle back in. So everything's looping back around to the heart to pick up the oxygen and spread throughout the body and come on back. So arteries move away from the heart. So once it leaves the heart, it has a lot of what? Andrew?
Then never mind.
It has a lot of what, Aliana? It has a lot of what, Nash?
Oxygen.
It has a lot of oxygen. Go write that down. Oxygen, we can write, instead of writing out as oxygen, how can we say, write oxygen? Isabel? Good. O2. So under arteries, Nash is just going to go ahead and write plus O2 or lots of O2, or maybe he'll draw, this is my heart, it's not very good, whatever. Maybe he'll draw an arrow showing the direction the blood is flowing through an artery away from the heart, carrying a lot of what?
Blood.
Oxygen. Thanks, Kohana. There we go.
Can I have a black marker?
Sure. Here we go.
You-
Okay. And what, and I know that this might not feel super clear right now, and that's okay. This is we're going really fast, and we will come back to this. I just want you to have these nuts and bolts before we go any further. Make sense? Okay. So, what is that other thing called that brings the blood back to the heart so we can get oxygen? Isabel. Veins. Good. Since Isabel, you already wrote something up here, go ahead and call on someone else to write veins. All right. Olive. And do you see how Nash drew the little diagram showing oxygen moving out for arteries? I would like you to also write veins moving away from the heart or moving towards the heart and show me on the diagram what that would look like. So first write it. Okay, now I would like you to flip open to this page. It has a diagram of the arteries and the veins. Yeah, kind of thing. It's really challenging. Like, let's just say, put one over there. There isn't actually one right there, but
It doesn't say anything about veins.
well, let's look. We have A for artery and V for vein. Right here. I want you to look at your diagram, and if you have your highlighter, which you should, your highlighter should be in your box, or a colored pencil. I want you to circle where you see all the arteries. Just the arteries. We know the arteries are arteries because they have an A after their name. Do you have a colored pencil? Okay. Do you know where to get the colored pencil?